Hello, friend. Today we discuss about the chemical bonding, the chemistry itself. Chemistry relates with the science, systematic study of chemicals, including the materials, so interaction of different compounds and form different materials as well as the substances. So basically, in the chemistry, the elements which have a specific property. So elements are various examples. Those are in the periodic table, and we can say elements are the various examples which are present in the periodic table. Most one, the hydrogen, helium. You can see from left to right the hydrogen atom. These are the elements, and very smallest particle is the atom. Hydrogen atom, helium atom, atomic number 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So this is the basic periodic table. However, back to the history of how this modern periodic table exists. Earlier, periodic table based on the atomic weight of the elements. Atomic weight of the elements. Later on, so many developments occurs in atomic structure, and therefore the modern periodic table is based on the atomic number. Very systematic arrangement, but this systematic arrangement exist of the element is very natural. This is whatever the uh, Earth we live in this planet, but the arrangement of different elements is itself a systematic arrangement. We can see 18 groups, 18 groups, group number 1, group number 2, group number 3. 18 groups are there, and start from the 1. Earlier, back to the historical aspect of the development of periodic table of the elements, the groups were uh, in order of the first day, second day, third day, fourth day, fifth day, sixth day, seventh A. And then the B part, and we have the zero part, zero itself, the inert gases. So this is the whole periodic table. But now the question is there: how compounds are formed? Two or more elements, two or more elements combined with various interactions. So those particular interactions are relevant with the uh, energy, energy and energy conversion. Whatever we can say that energy is transferred from one to other. So we can say how compound are formed, and then bonding is between two or more elements. So the question is there. For example, the very well known table salt, that is the sodium chloride, sodium Na represented by chemical symbol, and chlorine, the chemical symbol is Cl. So sodium chloride table salt which we are using the regularly. So now the question is there, how this NaCl is formed and why this NaCl represents the table salt. Sodium chloride, common name is the table salt, and all of you are using for the taste of food, that is the sodium chloride. So in between sodium and chlorine, how they can say how they relates with the bonding, how they can combine. The question is there. However, we can see the periodic table which is based on the atomic numbers, based on the atomic number of protons, and also equals with the number of electrons. So electronic electrons concept. Electrons like a negative charge particle, and all of the technology relates with the electrons. Modern technology, whatever the system. So because of the electron uh, relevance, all those technical technologies are there. So now the question is there, how the bond is formed between the sodium and chlorine in a simple example of the table salt. So this say uh, why sodium chloride, the physical state, however we can define that physical states are mostly of three types: solid one, liquid and gases. So physical state of sodium chloride is solid. Why? When we have to see the sodium itself, alone sodium, which is solid in condition. And but one more thing is there regarding the sodium. Sodium is a active metal. When sodium we can put in the uh, put in on open area, so this will react with the present environmental conditions, the oxygen and moisture, and this will get the compound. So that is the active metal, sodium itself. Whatever the Cl, Cl not, chlorine is the atom, chlorine element, but Cl2, chlorine gas. So why Cl2 is there? That is the also relevance with the electrons. So NaCl, what type of bond is present? How chemical bonding is there? What type of chemical bondings are there? And how this particular NaCl formula is formed? Why not NaCl2 and why not ClNa2 or different proportionate? So why NaCl with 1:1 proportionate? So the in this particular case, we have to see bonding, chemical bonding. So today's discussion, how chemical bond between the two elements which are present in a compound. The definition of compound is two or more elements combined and their stable form. Oxygen gas. Oxygen, O, represented by the chemical symbol oxygen. Element, O element. But one oxygen combined with another oxygen, and that is the we have to see O2, oxygen gas. One thing, oxygen element, oxygen element, oxygen gas. So there is difference. We have can see the periodic table where easily represented by that carbon, nitrogen, oxygen. So oxygen electronic configuration, electron number of electrons 8. So the question is there, compound, one oxygen, another oxygen. Carbon dioxide, the compound, one carbon, two oxygen. So why one carbon and two oxygen are there? Water, H2O. The chemical symbol is H2O. So H2O, water. So the question of water in case two hydrogen and one oxygen, two hydrogen and one oxygen, that is the water. So H2O, the chemical bonding is there between two hydrogen. Okay, two hydrogen and one oxygen. So H2O itself is the chemical compound, and where we can say that bonding is there between the two hydrogen and one oxygen. So how two hydrogens are used in water? So chemical symbol of compound H2O. So molecule, this is the smallest particle of a compound. The smallest particle of an element is the atom. So two atom or more atom of their respective elements, whatever though may be same of oxygen, okay, then different carbon monoxide, one carbon and one oxygen. Carbon dioxide, one carbon and two oxygen. So the now question is there, how chemical bond is formed and what compound is there? Yeah. So see we can already we have that the physical state, whether solid, whether liquid, whether gas is the form. So now we can say the bonding itself is relevant with the two or more atoms in a compound, and their strength is also concerned. So how they get the strength and become solid, become a liquid, become a gas. So chemical bonding itself is of electrons, electron transfer. And before that, we have to give the electron transfer. So chemical bonds are of the generally of three types: the covalent bonding, the ionic bonding, and coordinate bonding. So the question is there, how such type of bonding is there, and we can say the different elements which are present and their behavior. We can say here hydrogen, atomic number 1, oxygen, atomic number 8, sorry, atomic number here, the 8. 8 electronic configuration of oxygen, 1s2, 2s2, 2p4, hydrogen having 1s1. So two hydrogen combined with the oxygen and form H2O. So now we have to see this can be represented with the help of the chemical bonding. So before going to the chemical bonding, we have to see the Lewis symbols. So Lewis symbols exhibits their outermost electrons can be represented, can be in the form of the dot. So here different elements have their Lewis symbols, Lewis electronic dot structure, which can easily by Lewis dot structure we can easily define or visually see the bonding, chemical bonding. So here oxygen can be represented, oxygen itself having the 6 electron. So now the oxygen and combined with the lithium. So here Lewis symbols only shows the group valence or electrons that take part in the chemical bonding, and hence it is called the valence electron. The valence electron. Valence electrons are the outermost electrons present in an atom. In case of the lithium, electronic configuration of lithium, three electrons are there. So three electrons are present in their different atomic orbitals. Orbitals. Lithium can be represented by a single dot. So single dot is the valence electrons. So we can go further, whatever we can see the already the periodic table here, the lithium, beryllium, then the boron, carbon, nitrogen, oxygen, fluorine, neon. So the increasing order of the atomic number: lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, and fluorine 9, and neon is the 10. So electronic dot structure, whatever we can say, the Lewis dot structure of an element can be given by the different dots. So we see in the second periodic period where start from the lithium and last one is the neon. So lithium having outermost electron 1. In case of the boron, this is 2, and beryllium 2, and boron having the 3, carbon having the 4, and nitrogen having the 5, and oxygen having the 6, and fluorine having the 7. And what was the last one? Neon itself. So neon can be say the 8 electron. Oh yes, this one is one of the well-known rule, and that is the octet rule. So octet rule. So for completion of octet rule, either electrons can be transferred, either electrons can be purely transferred, and or electrons can be purely accepted. So such bonding, transfer of electron, and formation of cation and anion and bonding is called the ionic bond. So here the role of the Lewis structure that can easily show. So here easily can get the relevance of chemical bonding. So now significance of Lewis symbol, whatever that can be structure, like a electronic dot structure, and the number of dots around the symbol represents the number of valence electrons, and this number of common or group valency of the element, the group valency of the element is generally either equal to the number of dots in Lewis structure, Lewis symbol, or 8 minus, because overall octet rule can say that any of the things stable in on the earth, on the planet, and that must have outer shell must have the 8 electrons. But how we get the electrons, that is the nature of that particular element. Why? Because we can see the valence electrons in case of the lithium: 1, 2, 3, 4, 5, 6, 7, and last one the 8. So neon itself is the stable one, and that is the inert gas. So why neon is the example of the inert gas? So because here we can say uh, neon itself completes the octet around the valence, around the outer shell. So here the valence electrons are the number of electrons available in outer shell, and those available electrons in outer shell are the relevant with the chemical bonding, and that depends on the wholly the electronic configuration. But in case of further electronic configuration, valence electrons are there. So therefore we say uh, 1, valence electron, two valence electron, three valence electron. That depends on the atomic number, the electronic formula, the electronic configuration of the elements, and those are the whatever the a very strong work of our various scientists, and by which we get the electron. And because the story of electron is around 120 years when this was first invented, first discovered, whatever that. So this is the play of the game of electron. The whatever the electrons were discovered by in 1900. So since that, earlier there was the whatever where is the electron though not the thing, but in present context very advanced technologies, various useful technologies for the human being and relates with the electrons. So here valence electrons are the uh, outermost electrons generally. The electron one, and if in outer shell one electron is there, in outer shell two electrons are there, so two valence electron. So now we have can see that particular issue, the bonding. So regarding the bonding, uh, we can say that the bonding, chemical bonding, and that chemical bonding is of, however, types of electrovalent bonding, covalent bonding, and coordinate bonding. So there are three types of bonding between the elements of two atoms. Whatever two or more may be there, but we can simplify the use of the two atom. Two atoms, sodium and chlorine, sodium cation and chlorine anion. So why sodium cation is formed? So there are three types of bonding between the electrons of two atoms. These are single bond, double bond, triple bond, and a single bond is the bond where one pair of electrons take part in chemical bonding, and that is the two electron. Double bond is there in bonding, whereas two pairs of electron take part the chemical bonding. Four electrons are there. So double bond contains one and two pairs, and two pairs, that is the one pair includes the two electrons. So here the question is there, why how uh, the electrons come towards and form a chemical bond. This one is the most important concern: ionic bond, covalent bond, as well as coordinate bond. So out of these three types of bonding, and this one is in case of the covalent bonding. So in case of the covalent bonding, sharing of electron. So before discussing this, the chemical bonding are of the three types, and one is the ionic bonding. Here we can say the ionic bonds are formed between, generally, whatever the S block and P block elements. So in case of the sodium chloride is the ionic bond, and whatever the methane, carbon tetravalent, four electrons are there. Hydrogen, this combined with the hydrogen having the one electron, so four hydrogen with one carbon, the second type of bonding, that is the covalent bonding. So covalent bonding, the sharing of electron. In case of the ionic bonding, the electron transfer. So the third one is also the coordinate bonding. So what we have to see, uh, electrons are transferred, completely transferred, and electrons are shared. So sharing of electron is the covalent bonding, and transfer of electron and formation of cations and anions, that is of ionic bonding. And in case of the coordinate bonding, the electron pair is whole transferred. Here, the thing is there that so here the electron transfer one thing, the electron sharing another thing. So electrons sharing the formation of the covalent bond. So why electron sharing and why electron transfer? All those depends on the atomic structure of the particular element, because how many electrons are there in outermost electron, and outermost electrons play an important role in the chemical bonding. So here three different types: the covalent ionic bonding, covalent bonding, and the coordinate bonding. So in case of the covalent bonding, there may be single bond, double bond, triple bond. So now we have to come towards the first one, that is the electrovalent bond, and this can be correlates with the, so this one, the negative and positive ions are stabilized by electrostatic force of attraction. So this is the table salt. Case of the table salt. Table salt, the sodium chloride. Sodium chloride itself is the solid one. Na, sodium, natrium, and Na uh, further change into the sodium cation, and chlorine change into the chlorine anion, and both interact with each other, form a sodium chloride. So formation of sodium chloride, NaCl, this is one of the example of the ionic compound. So in this is whatever the ionic compound, ionic bonding, those are also the electrovalent. So electron completely transfer from the sodium. Here, one most information important concern is the already we have discussed about the octet rule. So what happen in case of the sodium? Outermost electron is one. So how sodium complete stable form? So for that purpose, the one electron we can see the periodic table where we can see the sodium. Sodium having the atomic number 11, okay, and electronic configuration is 1s2, 2s2, 2p6, and 3s1. So 3s1, one electron is there in case of the sodium. So this outermost electron, sorry, that is the electrovalency, also valence electrons. So and outermost electrons in case of the sodium, one electron. In case of the chlorine, here the seven electrons are there. So chlorine contains outermost electron 7. So with the addition of one electron to the chlorine, and this become chlorine anion. So therefore, in case of the chlorine anion, the Cl minus, the number of outermost electrons are 8. So this is the octet itself is completed. So wherefore, in case of the sodium, sodium having the one outermost electron, and that can be lost, that can be uh, uh, transferred, and this sodium is converted into the sodium plus sodium cation. So in case of an electronic configuration of sodium cation, that completes the octet. So this is the basic how any of the element want to octet in outermost orbital. So here the ionic bond itself is formed by the transfer of electron. So because of the cation and anion form in case of the sodium and chlorine. So here we can see the electronic configuration of sodium, the neon configuration 10 electron and 3s1, that is the outermost electron which is present in 3s subcell, 3s atomic orbital. And when one electron uh, is transferred, then this become the sodium cation, and this sodium cation combined with the chlorine anion. So chlorine anion having the outermost electron 8. Similarly, in case of the sodium cation, the number so in this particular case, the outer shell electrons are now the outer shell electron are 8. So that is the octet. In case of the sodium cation have outermost electrons are 8. So why we get the 8? This depends on the whatever the systematic arrangement of the periodic table. This one, sodium itself is losses one electron and formation of sodium cation, and sodium cation having the outermost 8 electrons. So therefore, octet rule can be followed here, and then the formation of the. Similarly, in case of the chlorine, the electronic atomic number is the 17. The electronic configuration, the neon configuration, then 3s2, 3p5. So in outer shell electrons are the what we have, the outer shell electron in case of the chlorine is the 3s to 3p5. So therefore, seven electrons in chlorine, and in chlorine anion, this is called the chloride ion. So here one electron, uh, chlorine atom get one electron from whatever the source. So in case of the sodium chloride, this chlorine atom get the electron from the sodium. So Cl minus itself having the electronic configuration, the neon electronic configuration of neon, 10 electrons are there, and this is the stable form. This neon is the inert gas. So here the uh, in case of the chlorine anion, this have completed the octet, and so therefore sodium chloride is formed. And example, this sodium chloride is ionic compound. Okay, so the characteristics of ionic compound that are the relevant when this dissolve, this can easily dissolve in water. So the role of sodium chloride in our life is very useful, and those we are taking the salt through the food, and that is the major constituent is sodium chloride. So sodium cation and chlorine anion. So sodium cation and chlorine anion both form um, uh, both combine with each other and form a strong bond, and that strong bond is the ionic bond. So therefore, we get the sodium chloride in the position of the solid state. But then we can say sodium chloride dissolved in water and form a solution, clear solution is formed. So that is because of the nature of sodium chloride. And nature of sodium chloride, that is because of the bonding. And here the bonding is of a specific bonding, and that is relevant with the electronic structure, electronic configuration of respective elements. So ionic bond, this is one type. Ionic bonds are formed because of the electron transfer. So completely electrons are transferred from one case that form the cation, and accepting the complete exception of electron the uh, from the other elements, and we get that is the anion. So cation and anions are formed because of the electron transfer, and they form very strong bond. The sodium chloride, the that is the whatever that is in solid state. Similarly, another example of ionic bond, that is the calcium fluoride. So in case of the calcium fluoride, calcium and fluorine. So calcium itself is the alkali earth metal, as we can see the periodic table for that. in that periodic table, the calcium, where is contained the calcium. So we can say here uh, the whatever calcium is where. Okay, so here we can say this one in the periodic table. Calcium, you can see this in second A group. Calcium, the atomic number is 20 and atomic weight is 40. So this calcium here and the fluorine is here, and that is in seventh A group, and the group is now 17 group. The atomic number is 9, and here electronic configuration is 1s2, 2s2, and 2p5. So 7 electrons are there in outermost, similar to chlorine, because the fluorine and chlorine both are the example of the halogens, and the halides means the chloride, the fluoride. So here the thing is there, calcium fluoride, and this calcium fluoride can be easily explained, and the one calcium can lose 2 electron and formation of calcium plus 2 cation. So 2 electrons are lost, completely transferred, and here in we get the calcium plus 2, and calcium plus 2 having the electronic configuration of inert gas. So it this can follow in case of the fluorine, because the fluorine having the 7 electrons, so in outermost electrons. So this so two fluorine atom take 2 electrons from the calcium, and calcium from the calcium plus 2, and so now the covalent bond. So covalent bond itself, this can be defined, this can be defined by the language, and here the postulation that covalent bond is formed by sharing of electron. Whatever the chlorine we are taking earlier, uh, in case of ionic bond, the chlorine get 1 electron from the sodium, and then they form the electrovalent or ionic bond. But here, the covalent bond, the second type of chemical bonding, this one is formed by the sharing of electron between two shells or subcells, whatever that particular thing. Atomic structure of chlorine atom, 17 electrons are there. How these 17 electrons are arranged? In their specific order. So therefore, 7 electrons are present in outermost shell or the subcell. The meaning of the cell and subshell, all of you are well known about the quantum number, and quantum numbers are, I have another video lecture on the quantum numbers, so that you can see my another video lecture on the quantum number. So 7 electrons in outermost shell or subshell. Quantum numbers can represent the position of the electron. So how these 7 electrons are arranged in their outermost shell or subshell? Quantum numbers, the shell number, the principal quantum number, that can be with the help of n, the azimuthal, that can be with the L, and that can be represented with the subcell. So shell, subcell, and then the atomic orbital. So here 7 electrons are in chlorine, and 1s2, 2s2, 2p6. Okay, then 3s2, 3p5. So here two subcell, the S subcell as well as the P subcell, and further. So Further, p subshell having the three atomic orbitals, the px, py, and pz. So this is the arrangement of outer shell or subshell electrons. So what happened here? One electron of one chlorine combined with another chlorine atoms electron. But here the sharing of electron. What about the, for example, the meaning of sharing is right for both atoms. Both atoms right to use that particular atom. But because of the use of those particular electrons, and they form a covalent bonding. But here the electrons are shared. So their sharing of electrons, if suppose one electron from one atom, another electron from the another atom, and they form the electron pair. So electron pair itself is the whatever. This can be further represented by, we have the various with the help of the electron dot structure, whatever the electronic structure. Here we can say the examples of the hydrogen, example of the oxygen, oxygen having the two electron pair, and in case of the one another example is the ozone, another are the NF3. So these are the various electronic dot structures. So now here also one of the third one, and that is the coordinate bonding. So let's we have some of the formula, some of the examples of the multiple choice question. So here we can say the for example, oxygen bond length is minimum, so that can be answered in the carbon dioxide because of the carbon, the covalent bonding. But here the formation of the covalent. So these are the few questions. The molecules are held together in a crystal also, and there is the another type of bonding. These are can be explained. Hydrogen bonding, another way, electrostatic, whatever that can explain already in the ionic bond. Someone other attractions. So those are also the bonding, like a hydrogen bond. Hydrogen bond. These are so basically ionic bond, covalent bond, and coordinate bond. And these are whatever the other types of bonding. In case of the hydrogen bonding, and there are some other atomic uh, properties are relevant. For example, the electronegativity. So hydrogen bonding, one thing. However, this is the multiple choice questions, but here the held together in this is the of the crystal. So hydrogen bonding that is present in water. So that's H2O is on liquid condition because of the hydro electrostatic attraction. Some other van der Waals attraction and dipole. So this one is the last one. Okay. So now we I can summarize the all of the uh, lecture, and here later we can summarize that bonding itself is the force of attraction, whatever the conditions. Similarly, the other van der Waals forces, the hydrogen bonding, then other attractions, the metal. But basically, the three different types of bonding, chemical bondings are there. One is the ionic bond. Ionic bond is electrovalent bond. Another name, electrons transfer. Then we have the covalent bond. Covalent bonding is because of the sharing of electrons. So one electron transfer, as we have seen the case of the table salt. Sodium is completely transferred its electron and outermost electron. So one more thing is there, and that uh, we can say that particular thing is relevant with the whatever the periodic table. So this periodic table explains overall which type of bonding will be there. You can see electrovalent elements, electropositive elements, one thing, electronegative elements. So here we can say the when we have to see the periodic table left side, in case of the left side, alkali metal, the group 1. So in case of the group 1, one electron is there. So for the octet rule, for in outermost octet rule, this can lose one electron. So that is the electropositive elements. Electropositive elements are on the left side. Left side, the we have group number 1, and the group number 1, the hydrogen. Then below are the lithium, sodium, potassium, rubidium, francium. So they easily loses one electron. When we have to come towards the carbon family, the carbon. So in case of the carbon, hydrocarbons, the organic compounds are the covalent in nature. The one carbon example is the methane. So CH4 contains the four covalent bonds, and one, the third one, the coordinate bond where the electron pairs are donated, but right is there. So covalent bonding, that is also the but in that particular case electron pair whole is transferred. So let's this is very interesting topic regarding the chemical bonding, and with the help of chemical bonding, sure we can get more different type of technology, but we have to know the fundamental of the bonding. So bonding like a connection, how our body is bonded with the different parts. The hand is bonded, the length, the legs are bonded. So how they are bonding, and this is the bonding. So in case of the various chemicals, the bonding itself is important, and that is purely relevant with the their functions. How semiconductors, various semiconductors used in different technologies. So that is because of the bonding present in that particular semiconductor material. So that is all about the chemical bonding. Okay, best wishes to all.